Hi, hope you are doing well. So, in today's video, I am going to discuss in detail about MMC HVDC modeling in PLECS software. So, PLECS software is basically one of the uh, best tool in which you can develop your HVDC systems, or you can develop any other system related to electrical, you know, terminology, or thermal or mechanical. There are different libraries given. All right. So here, the beauty of this software is lies here. You see, this is a this is an MMC, you know, converter, which is basically synchronized with a grid. And here on the right side, you can see the DC sources are connected. Here you can also connect your HVDC system or HVDC transmission line. You can also develop a back-to-back MMC HVDC system over here, right? Now, first of all, let me run this model and show you the simulation. So this simulation is running. So you can see here that this is the output voltage of the converter, and this is the grid current, this is the grid voltage, and these are the submodule voltages. So and this is the active power, and this is the reactive power, right? Now, why I am saying that this is a very good software, because the model that you are just seeing right now is the detailed model. Detailed model meaning that on the upper arm. So in MMC, we have this is the upper arm, this is the lower arm, and we have each upper and lower arm make a complete single phase. So we have a three-phase system, right? Now this upper arm consists of 30 submodules. This upper arm consists of 30 submodules, and even you can see that this is just an half bridge, and this is just a single capacitor, right? But how it is equal to exactly equal to 30 submodules? Because in Plex, the beauty of the Plex is that you can basically have a define the number of cells or the number of bridges inside this configurable block, right? So you have two types of half bridges that are given to you. One is called as low side connected, and the other one is called as high side connected. So let me show you that how you can basically access it. So here, this is the library browser. So in Plex, you have a library browser through which you can uh, access different components. Here you have and this is used for the connectivity purpose. This is electrical port when you develop any subsystem. This is a tag, and this is a wire multiplexer, wire selector, then electrical ground. Then you have different sources: DC voltage, AC voltage, controlled current and voltage sources. You have different types of meters: voltage, current, and three phase. This is the beauty of the software, that three phase system comes with the current and as well as the voltage, right? So you just need to connect this, and you can easily mirror both the voltage and the current. See here, you don't need to connect separate connectors. plus in the passive components you can find different passive things. uh, then you have a power semiconductor, so you can find different types of switches, diodes, and all that, thyristor, MOSFET, IGBT, plus there are different types of the uh, those semiconductors, such as this one. You see, IGBT with a limited di by dt, and here you see a simple IGBT. Then you have power modules. So in the power modules, you can find that there exists a simple half bridge. If you are modeling MMC, you can either use single IGBT or IGBT with diode. If you are if you have a limited time, you can directly use this half bridge low side or half bridge high side. Let me show you. So you just need to click in and drag it inside the this. So you see, this is this one. So it is a low side. So here you can define the configuration, like you want a sub-cycle average. So it is defined here that the sub-cycle, what is sub-cycle average? The component is modeled with the control voltage and current sources. The input are the relative on times of the semiconductor with the values between 0 and 1, right? Whereas the switch is the ideal switch, right? So it is up to you. If you make it the sub-cycle, these options will be available. If you make it switch, these options are gone. So better you can make it sub-cycle average, just to save your time. So with this you can basically define the number of submodules in the form of array, in the form of vector. You can see the number of submodules are this vector uh, comma 2, right? So we have defined, so basically there are 30 submodules. Believe me, these are the 30 submodules in the upper arm and 30 submodules in the lower arm. While modeling in other softwares, this option is not available. This is only available in the PLECS, right? So right now you can even make it 100 submodules in the upper arm and 100 submodules in the lower arm, right? This is possible just by changing the simulation parameters. So you need to go into the simulation and opt for the simulation parameters. Then inside the simulation parameters you have different options such as solver, what is start time, what is the time span, how much time you need to run the simulation, maximum step size, and all that uh, related to different options related to the simulation, diagnostics, and then the initialization. In the initialization, you can define the different parameters. So here you can see number of submodules is 30. So there are 30 submodules. You can just make it 100 submodules. So right now we have a grid voltage as 100 kV, frequency of 50 hertz. We have set the active power as 150 megawatt, whereas Q is 0, and these are the different terms. We have a submodule capacitance of 20 milli right now, right? So this is one of the, yeah. Let me show you the control setup. So we have a classic MMC control where we are taking the active and reactive power as an input, and we are generating the reference signal. These are the grid voltages and the currents. We are using the ABC to DQ transformation, and obviously we need the theta as well. So this theta will be used when we convert back our reference signal into the DQ to the ABC. This is our This is our control block where we are controlling the, you know, the D and Q terms with the cross coupling. All right. Then this reference signal goes into the the other block. Now the beauty of the software is also that there are subsystems like this one. If I open this now, if I want to go outside, just need to click the view and go to parent. When you click go to parent, it will take you from where you get in. Also, this is also the child one. Go to the parent. So this is go to the parent. Then again go to view. If this go to parent is disabled, it means that you are on the very front of your simulation, right? And this is our model. So this the reference signal comes in here through this PABC. These are the three phase our reference signals. These are the our arm currents, and these are our capacitor, uh, voltages that we have just made. Now you see, um, using the even you can see if you open this capacitor voltage here, you can see that the capacitance is defined as a vector, and also the initial voltage is also defined as a vector. So Plex has basically you know uh, giving you an opportunity to even model your actual uh, MMC system, where you can have hundreds of submodules, and that will be a detailed model, not a not the average or the we call it, yes, we call it an average model. So this is a detailed model. If you go inside this, you can basically find um, a PWM control for each arm. You can see this is a circulating current control which is currently disabled. I will enable it. You can see here that the arm currents and the capacitor voltages are going inside each arm. This one. So here is the PWM control. So this PWM is going in this voltage balancing control. This is the capacitor voltages of the arm, and this is the arm current. So based on the capacitor voltage and the arm current, the signals are generated, and those signals again goes into the respective arms for the uh, submodule operation, right? Now, if you want to check how this submodule voltage balancing is working, so basically on the outside you can see that there exists frequency is defined, and as well as the number of modules are defined, which is 30. Now if you right click on this and go to the subsystem, so then you need to go to the look under mask. So here you can see that there is a C script option. This is also the beauty of this, that you can also use the C code inside this for the uh, you know modeling and control purpose. So in the C code, you can declare your states, different states, like uh, what is at index, what is the capacitor of the index of the capacitor, voltage of the capacitor, and all that. Uh, then you have the start function. You have defined different parameters, different sizes. This is the output function. Now here, based on the arm current and the capacitor voltages, are the capacitors are sorted, or the submodules are sorted based on this. um, and there and then the respective signal is generated and transmitted to the you know for the submodule operation. So again, go to view and go to parent. So this is our active power. Active power is set perfectly. This is our reactive power is set to nearly to 0. So this is 0, and here you can see that these are some module voltages, right? So use this software for your modeling purpose. It will be a very good start. You can get a student license for the 3 months from the PLECS. If you have any question, you can comment. Thank you.